I'm Scott Hansen. I'm a professor at Southern Utah University, and this module of SolidWorks will include instruction on how to use the mechanical mates command. We will use parts that were created in the previous modules, and we will create an assembly. So we'll move the cursor to the upper left portion of the screen and left click on the little white piece of paper. And this time we're going to select the assembly icon, which is in the middle, and we'll left click on OK. Now, if you have left your files open from the previous modules, they should appear in the Open Documents dialog box here. I have not left mine open, so I'll have to go find them. So cam case 1 is the first thing that I'm going to import. It'll be hooked to the cursor, so I simply left click one time and SolidWorks will place that part. Then we move our cursor to the upper left portion of the screen and left click on Insert Components. We'll left click on Browse. We'll left click on Lifter 1. We'll left click on Open. Place that. We'll left click on Insert Components again. We'll left click on Browse. And we'll left click on Lobe 1. Left click on Open. And we'll place our lobe. Now I'm going to use the mouse wheel to scroll back, and then I'm going to push the mouse wheel down and tip the entire assembly up so that we can see what's going on and assemble this assembly together. I'm going to move the camshaft lobe off of the case. Then I'm going to left click out here in the workspace so that no surfaces are selected. And then we'll start by using the mate command similar to what we did with the piston assembly. And that is, we'll left click on mate. We'll move our cursor over the lifter body. Once it becomes highlighted, we'll left click once. We'll move our cursor inside the cylinder bore. Once it becomes highlighted, we'll left click once. Now if SolidWorks tries to insert the lifter in the bore upside down, we simply left click on the mate alignment icon and it will flip it over. And then we'll left click on the green check mark twice. So now the lifter is mated to the lifter bore. I'll left click out in the work area so I don't have any other surfaces selected. We'll left click on mate again, and we'll left click on the camshaft lobe, the hole that's in the center of it. Left click once, and then we'll move the cursor over the pin that's created in the piston case or the camshaft case. We'll left click once, and we'll left click on the green check mark twice. And now we have camshaft lobe is centered on that pin. I'm going to push the mouse wheel down and we'll get a view of the underside here, and we'll slide this back and forth. Then I'm going to left click out in the workspace. I'm going to left click on mate. I'm going to push the mouse wheel down. I'm going to left click on this side of the camshaft lobe and push the mouse wheel down again and rotate the case around so that I have access to this side of the camshaft lobe or camshaft case. And then we'll push the mouse wheel down, rotate the part back around so we can see. At the same time, we're going to left click on the distance icon, which looks like it's inactive but really isn't. Left click on that, and we'll enter 0.1375, and it's off center just a little bit, but nothing that's too crucial for our exercise here. And we'll left click on the green check mark twice. We'll push the mouse wheel down, rotate the part around, and so now the camshaft lobe is constrained on the case. Now if you haven't noticed already, we have a serious interference problem, and that's all part of this module. So we're going to go in and edit the camshaft lobe so that we are not having this part collision that you're seeing right now. So we'll move our cursor onto the surface of the camshaft lobe. We'll right click and we'll left click on Edit Sketch, and I need to save it first. So we'll go up and save. Then we'll right click on the camshaft lobe, left click on Edit Sketch, and The camshaft lobe I updated from 2 to 1.5. So if you want to change this dimension, it'll need to be 1.5 or shorter. We'll enter 1.25. Then we'll change the diameter of the base circle to 1.75, and we'll change the diameter of the nose to 0.75. Then we'll hit enter. Left click on the green check mark, right click on exit sketch. So there's what the new camshaft lobe is going to look like, and it may need to be edited again. We'll go back and do that if we have to. Then we'll right click again and left click on edit assembly 3, and this gets us out of the edit assembly area, which is where we're at right now. And we'll rotate this around and see, and we may still have some contact. Probably wouldn't hurt to go in and change the shorten up the centers one more time. So I'm going to move my cursor over the side of the part, right click, I'm going to left click on edit sketch, and I'm going to double click on this 1.25 and change it to 1.125, and then we'll left click on the green check mark, we'll right click on exit sketch, move the part around, we'll right click again, left click on edit assembly 3, and we should be good to go now. Now we have plenty of room. So now we're going to utilize the mechanical mate command. Up to this point, mates have only allowed for 2 selections. The surface of our camshaft lobe actually has 4 selections that will need to be made, not including the foot or face of the lifter. So I'm going to left click out here in the workspace, we'll left click on mate, and then we'll go down here to the mechanical mates box, expand that, and these are the different types of mechanical mates, and we're going to left click on cam follower icon. So the mate selection here, this is the lobe that we created that will allow for the multiple selections. And then you see under here is the cam follower. That's going to be the foot of the lifter here. So the mate selections dialog box is highlighted. I'm going to left click on this surface. I'm going to left click on this surface. I'm going to rotate the part around, pushing the mouse wheel down. Left click on this surface and left click on that surface. Push the mouse wheel down. So we've made multiple selections. Now we move to the cam follower area. We left click inside the cam follower box to make that active, and we move our cursor over the follower and left click one time. If SolidWorks pulls the lifter down in contact with the cam lobe, then we've made a successful mate, and it looks like we're good. Then we'll left click on the green check mark. Now this error box will come up because our camshaft lobe is not a true camshaft lobe. It actually takes very complex geometry to create one. It utilizes a number of ellipses and arcs. And so written in the software, it's concerned that we have a flat edge on our camshaft lobe, which for this exercise is okay. But to actually create a true camshaft lobe is a very intense process. So we're just going to left click on OK. We acknowledge that our camshaft lobe has straight edges, and we're willing to live with that. And then we'll left click on the green check mark. We'll push the mouse wheel down, and you'll see that the lifter now follows the camshaft lobe. It does come off of the surface of the camshaft lobe a little bit, and that's because we have straight edges on our camshaft lobe, and you typically don't find those on a true camshaft if there's any kind of high rate of spring pressure or high RPM involved with the system of those parts. And we'll push the mouse wheel down. We'll left click out here in space, and that concludes the module on use of the mechanical mates mate command.